Okay, hello everyone. I'm Peter. So this is my channel about how to learn the high school physics wells, and today we're talking about the topics about the matters. So when we are in the senior schools, there's someone told us that the nature actually composed two things. First one will be the matters, and another actually is start from the energies. So there is some. So if we want to prove of this, well, we got to, or maybe we want to know what is truth. So we got to first talking about what is the matter, right? So the first one that the matters. So the matter actually the ideas that if you want if you once thinking about where am I and where I come from, or maybe why what something made up all of these things in the world. So maybe you're a physics, you're really like this one, so you can know that. And a man before the centuries, about 300 years ago, and we call the very famous philosopher called Aristotle, and another the Leucippus. So these philosophies first thinking about what is the root and what is the matters. So the Aristotle thinks that everything the matters can slice into the matter pieces, and you can each species can slice into another another species, right? So we think that this property we call then is a continuant. However, the Leucippus thinks that everything is just can be composed by an atoms. So the atom you cannot slice the atoms because the atom is the minus units in the words. However, the philosophy only talking about this one, and because this is the physics, this is not the real physics because this is called a metaphysics. So the metaphysics means that they're just thinkings. They just think, only thinking, but no experiment. This one, okay. So before century, 300 years ago, this is really important things. Okay. So when we finish, if we start to focus on what things can be composed matters. In the 1763, in the 1766, people calls that Lavoisier. Lavoisier in he proposed a theory about that he do lots of the experiments, and finally he proposed that the max conservation. So actually, the Lavoisier actually is a chemist. So he do lots of experiments. So this is based on the experiment. Okay, so and actually there is still other people who propose a theory about the laws of the definite proportion. And the multiple proportion. So these kinds and the people who calls the Daltons. The Daltons propose a series in 1803, and we call the atomic series. And in the series, it's talking about that everything is based on everything can the atom is the minus the minus the minus is the minus the minus matters in the words, and actually the reaction and the reaction, the chemical reaction before the chemical reaction and after the chemical reaction, everything will be correspond to the max conservations, and also have been applied the definite proportion and the particle proportion. So all these things actually very important for all of us. So, however, it's that the Dalton just proposed the atomic theory, but because this is just a theory, it doesn't have the, it didn't it just, although he based on the definite proportion, multiple proportion, and the max compensation laws. However, it didn't have the direct observation about all these atomics. And when 1823, and there's a biologics we call the Browns. And the Browns actually said he is I told you that he is a German, he is a biologist. And the biologist is think that there is some pollen. So the pollens actually he can the pollens in the water and start to use the microscope to observe it. However, he find that the pollen actually really interesting ones. So when the pollens in the waters, and we find out that were bombarded with something, so the pollen start to randomly walk. So the pollen is start to rendering was really interesting that the phenomenon. So someone will start to guess what is right, what's wrong with the phenomenon, and the first thing is that the brown thinks that maybe just alive. However, this is not just life. So however, this is not life cells. Actually, this is really cool. However, the people didn't know why until that in the 1904, and a man who called Albert Einstein. The Albert Einstein proposed and diffusion equations. And Einstein proposed diffusion equations. This one can help us to understand why the pollens are bombarded with some things. So actually, finally, Einstein Einstein and the Pallant get a result. That the result will be the H2O molecule bombarded with the pollen. So because these bombers will cause the rendering works. Okay, so in the 1904. However, it's just an indirect, actually just indirect proof. Okay, so because this is just indirect proof, so that the Albert Einstein said that. So we just start from, if you start to believe that there's a models, there is something will compose all the things, then how to use these kinds of concept to model the structure of the matters. So the first one will be that we know that there is some states of the matters. So the first state that we may be the gas. So the gas means that there's some molecules there's some molecules in the airs, right? And the molecule in the air actually, if the molecules is really far enough, so this distance will be the delta x is really far enough, and they will start to colliding each other. So we call this is the gas, and another state we call the liquid. And the liquid actually really will be collided together, and maybe however the distance of the molecules actually is nearly than the gas, and also the final state will be the solid. And the solids actually that's the molecule will be stacked together and stacked together wells just like this one, and maybe it will just vibrate. It will just vibrate in this. It will just vibrating in these positions. So this is the state of the matter actually will can form. There is some formation of models. So we call this atomic models to help us to construct our concept about the matters. Okay, so if however in that just in about in the 1950 to the 1962, and because the technology apparatus is really frozen, right? So some kinds of microscopy will be discovered. So the first I think that the STM and the AFN and all this is counting from, because all this we can use it to see the direct observation of the atoms. So it is really cool apparatus. So for example, the microscopy of the STM we use the scaling tolerance, and the scaling tolerance current is really cool technology, so we can use it. And the AFM, we use the atomic force. So we can use the van der Waals force to help us to try to detect the atoms in the layer of the atomic in the surface of the layers. So this is really cool things. Okay, so today we finish our matters about everything is based on the atoms, and the next section we will start to talking about why we can the fancy structure of the atoms and molecules, and also we will know some development about the cool subparticles in the world. So this is today's programs. Okay, so see you next time.